let's squeeze one last paradox in if you have time, which is Simpson's paradox.
Sure. Well, we
We started that with
sneakily we
vaccines.
sneakily talked a little bit about that
Yeah.
with the Overton window, because that's an example where in each group, if you divide people up by their birth cohort, they generally become more liberal over time. And you can focus on particular questions. If you look at things that pertain to racism and sexism and homosexuality, as we've talked about, people tend toward more liberal over time within each group. But now, when you put all the groups together, it tends toward more conservative. And sorry, by age, I misspoke a little bit there. The key part of this example is that we have to look at people by age. And so this is an example where all of the groups are going in one direction. And then when you put them together, the aggregated average goes in the opposite direction. So that's Simpson's paradox.
Yeah, I think our discussion earlier of the Overton window should make that clear. Yeah, it's a very interesting effect. It's one that's very easily visualized. It's the kind of thing that I'm sure you have a few visualizations in your book that make it crystal clear instantly. When you see the chart, it's this like no brainer ability to understand this apparent paradox.
Yeah, the visualizations help a lot. And in fact, the conclusion is the resolution of the paradox is that there is no paradox. This is something that can happen in a data set, and there's
Right.
just no reason to expect otherwise.
Yeah, exactly.
Once you look at a picture, one of my examples is looking at penguins. And if you look at a particular species of penguin, there is a correlation between the weight of the individual penguins and the lengths of their beaks. And it makes perfect sense because a bigger penguin probably has a bigger beak.
Mhm.
So if you look within any given species, you see the positive correlation that you expect. But it turns out that if you take a whole bunch of different penguin species and you lump them all together, because the different species have both different weights and different beak sizes, they end up in these clusters that are in different parts of the plane. And if you draw a line between the clusters, it happens to have a negative slope.
Mhm.
And the resolution of that paradox is kind of like the old joke where you go to the doctor and you say, "Doctor, it hurts when I do this." And the doctor says, "Well, don't do that." That is Simpson's paradox. It's, "Doctor, when I take a whole bunch of disparate groups and I put them together and I compute aggregate statistics, I get confusing, meaningless results." And the doctor says, "So don't do that."